Hello friends, this video on triangles part 5 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 4. Let's try to prove converse of Thayer's theorem. To prove the converse, let's draw these lines. So once we have these lines drawn, let's draw the points, 1 unit each. In this also let's draw the points. So once we have the points drawn, let's draw the lines. This line is drawn, this line is drawn, and we'll observe that these lines are parallel. What we have done, we have just drawn these two lines at any angle theta, let's suppose. We have drawn these points 1 unit each to the side, and this is 3, this is 3, we have joined these 2 points. This is 5 points, this is 5 points, join this. This is 6 points, this is 6 points, because if you see 1, 2, 3, 4, 5, 6, 6 points, 6 points, just drawn the line and we've observed that these lines are parallel. This is L, this is M, and this is N. This line is LMN, so L is parallel to M is parallel to N. This is our observation. Please make a note, what we have done in earlier case, we have drawn the parallel line and we have observed that the ratio was equal. In this case, what we are doing, we are assuming the ratio is equal because this is 3 unit, this is 3 unit, this is 5, this is 5. So this 3 by 5, you see, right? This is 2 and this is 1 actually. This is 3 unit, this is 2 unit, this is 1 unit. With the ratio constant, we are drawing the lines and then we are observing that the lines are parallel. And this is why it is converse of Thayer's theorem. Thayer's theorem says that parallel lines means proportional. Converse, this is Thayer's, and converse, in converse what we are doing? Converse, we are taking proportional points and then we are saying that this implies parallel lines. So here we got proportional points and then we've added this, we have joined these and we have found the lines to be parallel. Let's prove this. To prove this, first let's understand the Thayer's theorem. Once again, converse of Thayer's theorem. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. That is, this is the triangle. If this is the line, if this line divides the triangle in the same ratio, then it is parallel. For example, these are D and E points. So the given is AD by DB is equal to A by EC. That is given. That is, it is proportional. We have to prove that DE is parallel to BC. Correct? In earlier case in Thayer's theorem, we were given that D is parallel to BC and we have to prove that AD is by BD is equal to A by EC. In this case, other way around. In this case, we are given that AD by BD is equal to A by AC. That means the lines are, this line is dividing this, D and E is dividing this line AB and AC proportionally. That is AD by DB is equal to A by AC. And we have to prove that D is parallel to BC. To prove this, let's do one thing. Let's draw this line, E dash, D dash, and let's assume that DE dash is parallel to BC. Okay. Let's assume DE dash is parallel to BC, right? And DE is not parallel to BC, obviously. It's not parallel to BC. So we have to assume this, it's not parallel. We have to assume, we are assuming that DE is parallel to BC. So if we are assuming this, by assuming this, let's come to some conclusion and we can prove that whatever conclusion we are coming to is wrong. And then we can assume that whatever assumption we have taken is wrong. Correct? See, if I'm assuming, I'm following the method of induction here, I'm assuming DE dash is parallel to BC, and then parallelly I'll try to show that whatever results I got by assuming this is wrong, and then that means that my assumption is incorrect. So let's follow this. If I assume that DE dash is parallel to BC, then in that case, by applying Thayer's theorem, I get AD by DB is equal to AE dash by E dash. Correct? If I am assuming that DE dash is parallel to BC, so in that case this statement is true, right? Actually this is not true, don't get confused. This is true if we assume DE dash is parallel to BC. Repeat it once again, right? Since we assume that DE dash is parallel to BC, then this is true, correct? Now AD by BD is equal to AE by AC, already given, right? AD by BD is equal to AE by AC. So instead of AD by BD, I'll write AE by AC. So this becomes AE by EC is equal to AE dash by E dash C, correct? Going by this equation, looking at this equation, I can say that E and E dash coincide, because AE by EC is equal to AE dash by E dash C. That means E and E dash is the same point I'm talking about. Thus, we can say that DE is parallel to BC. Why? Because DE dash is parallel to BC, we assume, and we know that E is E dash, right? So instead of DE dash, I can write D. This is D is parallel to BC, and this is very simple. What we have done, we have just taken any point E dash, and we assume that DE dash is parallel to BC, and then we found that E dash and E is same point actually, and then we concluded that D is parallel to. Let's have some tips to remember Thayer's theorem. So if you see this triangle, let's suppose ABC and D, right? So Thayer's theorem is true only if D is parallel to BC. This is given. So this is X, this is Y, correct? This is one line segment, this is one line segment, and let's suppose this is X plus Y. This is also one line segment, correct? Similarly, this will be X dash here, this is Y dash here, and this is X plus Y dash, X dash plus Y dash. You take any sector and divide it same. That is, if you take X by Y, if you take by Y, this will be equal to X dash by Y dash. If you take this and the bigger side, that is, if you take X by X plus Y, this should be equal to X dash by X dash plus Y dash. If you take this side, Y, if you say Y by X plus Y, this will be equal to Y dash by X dash plus Y dash. If you take Y by X, this will be equal to Y dash by X. You not remember anything, just remember this thing, that when the triangle divide, if this D is dividing this AB into two parts, you get X part and Y part, also X plus Y is part, right? So if you say X by Y, that should be equal to X dash by Y dash. If you say Y by X, it should be equal to Y dash by X dash. If you say X by X plus Y, this should be equal to X by X dash plus Y dash. When you say Y by Y X plus Y, this should be equal to Y dash by X dash plus Y dash. In this case, Thayer's theorem also really am saying that. Also we'll prove that if this is Z actually, we'll also prove this. If this is Z, this is Z dash, then Z by, or you can say X by, if you take X also, X by Z will also be equal to X dash by Z dash. If you take Y by Z, that will become Y dash by Z dash. Why? Because these two triangles are similar. We'll prove that. Just remember, in any case, Thayer's theorem says that this is the triangle. This point divides this line AB into two parts X and Y, and E points divide this line into X dash and Y dash. So if we take this part X divided by Y, this is equal to X dash divided by Y dash. So don't get confused. You can take anything. You can take X by Y is equal to X dash by Y dash. X by X plus Y is equal to X dash by X dash plus Y dash. Y by X plus Y is equal to Y dash by X plus Y. Anything you can take. Correct? Just remember, this D divides line. The real form of Thayer's theorem is this only. You have this line AB, D divides it into two parts X and Y. E divides AC into X dash and Y dash. So X by Y is equal to X dash by Y dash. That's the real form of Thayer's theorem. Plus, but all these are also true. Will be true. Correct? Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.